All right, you guys, today we're going to build the unit circle. I just felt like yesterday we needed a little bit more, a lot more, but we needed to do this again. So here's what we're going to do. We're going to label our unit circle first. And remember, all the way around was 2 pi. We are going to label it in radians today. Okay, so I want it in radians. All right, and we're going to start with the quadrantals. I talked about them yesterday. The quadrantals are 0 and 90 and 180 and 270 and then 360 again. But we're going to do it in radians. And remember, 180 is the same as pi. And this is 0. So if this is pi, half of pi is pi over 2. Okay? So 1/2 pi, 2/2 pi, 3/2 pi. So it's 3 pi over 2. Okay? Now, from here to here was 30 degrees. It's also known as pi over 6. Okay? So we're going to go pi over 6. This would be 2 pi over 6, which is pi over 3. We're going to come back to that. 3 pi over 6, 4 pi over 6, 5 pi over 6. This is going to make more sense today. 6 pi over 6, 7 pi over 6. So this is a 7 pi over 6. 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. You might be wondering, why didn't I write down 2 pi over 6? Well, I didn't because that's pi over 3. And if you think about the unit circle, if this is 0, here's what it really means. This is 1/3 of a pi, okay? I'm sorry, let me get there. From here to here is 1/3. From here to here is 2/3. And from here to here is 3/3, which makes 1 whole pi. So we're just going to go, when we learn to label our unit circle, I would like you to go 0, pi over 2, pi, 3 pi over 2. Then go pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Then I don't care what's next, but I'm going to go pi over 3 this time, 2 pi over 3 this time. Okay, so it's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3 here. 5 pi over 3 here, and then 6 pi over 3. The only thing left to do are 45s, which is pi over 4. So this is 1 pi over 4. This would be 2 pi over 4. This is 3 pi over 4. This would be 4 pi over 4 right here. And this would be 5 pi over 4. 6 pi over 4, 7 pi over 4. Okay, so we have now labeled all the radians all the way around the unit circle. What we're going to do next is I had you cut out these guys. These triangles are special triangles. We have that triangle, and we have that triangle, and then we have the other triangle, that triangle. And we're going to use all 3 of these, okay? So, as an aside, I'm going to come down here for a second and just, I don't want to take up too much room because we're going to write our coordinates here in a minute. Let me just back that off and move this down. Okay, so I want you to be able to see this. I'm going to try and do a quick tracing of this. Okay, so we talked yesterday about why it's called the unit circle. And it's called the unit circle because the radius is 1, okay? And this would be a 30 degree, 90 degree, 60 degree triangle. And what we learned in geometry was that this would be A, this would be 2A, and this would be A rad 3. Okay, so I'm not going to go through the Pythagorean theorem and all that good stuff, but we know this is 1 because it's a unit circle, and this would be a radius. okay? So if that's what 2a equals, then this is 1/2. And this guy becomes rad 3 over 2 because it's 1/2 rad 3. Now, this triangle would be the 60, and I'm not going to write it out because the 60 is simply this, whoops, it's simply this guy that's been turned up on its side. What I am going to have you do with all your 60s is I want you to go and put a 60 here. I don't care about the 30 up there. I did it here just to show you, but I want the 60 there, and all your 30s can have 30s. We're also going to take and write this as pi over 6. And this one's going to be pi over 3. Not all of them the same, so don't make them all pi over 6 and all pi over 3. I'll show you what I mean in a minute. One more thing, the 45. Okay, so the 45, 45, 90 is also a special right triangle. And we learned all this in geometry. And I had a lot of you guys in geometry, so I know you learned it. Whether you retained it is another story. But, so this is a 45 degree, and this is a 90, so that makes this 45, okay? Now, we know that this is 1, and what we would deduce if we did Pythagorean theorem is that this is rad 2 over 2, and this is rad 2 over 2. If I square this, I get a 4 in the bottom, and I get a 2 up top. So 2/4 and 2/4 makes 4/4, which is 1. This is going to be, just label one of them so far, pi over 4. So you're going to have triangle like this, where I don't care if you put 30. I think that's a great idea, but I want you to have pi over 6 on this guy, all right? And then I'm going to have you label it as rad 3 over 2 and 1/2 and 1. The pi over 6. I want it labeled like that. Your 45, 45, 90. You can put 45 degrees in here, pi over 4 in here. Then I want you to write rad 2 over 2, rad 2 over 2, and 1. Okay? And then your pi over 3. Your pi over 3. I want 60 here. I want pi over 3 there. This side is now the 1/2. This side is the rad 3 over 2. And this side is 1. Okay? So we're going to have these 3 for our first quadrant. Okay? Because we're going to do something with that. Now, I'm not going to do all of the unit circle with you. I'm going to show you how to do the pi over 6s. Then I want you to do the pi over 4s and the pi over 3s on your own. So I'm going to put the pi over 3 and pi over 4 away. Okay? Now, what I want you to do is you should also have this sheet. You should also have this sheet because we're going to build the pi over 6 triangles right now, and then I'm going to come back and we're going to talk about how to fill in the table. So here's what we're going to do. We're going to take the pi over 6 and we're going to put it on the triangle, and it's made so that it fits this triangle. And we know that this is pi over 6. We've already labeled it. We know what the x coordinate is now, and we know what the y coordinate is now. So what I want you to do is write rad 3 over 2, comma 1/2. Okay? And leave it there. Okay? Now, let's grab another triangle. And it's not going to be shaded like that because I'm going to have to flip it over here. But which one is this? Okay? Well, it's the 5 pi over 6. So I'm going to take and write 5 pi over 6. Now, what we learned yesterday when we talked about this, and you may or may not remember this, is that this point here and this point here have some things in common. They both have the same height. So that means their y value is going to be the same. So I want you to put 1/2 right here. This is still going to be 1, but what happens to the x coordinate? It becomes negative rad 3 over 2. Negative rad 3 over 2. So My coordinates up here are negative rad 3 over 2 and 1/2. I'm going to leave that triangle there. Now I'm going to take this triangle and I'm going to put it here. What angle would that be? This one. It is 7 pi over 6. So I'm just sliding it down to see what my radian measure is. It's 7 pi over 6. Well, you can compare it a number of ways, but look, these two triangles have the same x value. So I have negative rad 3 over 2. This is still 1. And now what about this value? It's going to be the same length as that, only it's down here. So it's negative 1/2. So now I can write down these coordinates. And they're going to be negative rad 3 over 2, comma, negative 1/2. Okay? And then finally, I'm going to put this one in, and I got to flip him over too. And I'm going to put him there. And then I'm going to say, what angle is this right here at this point? Ah, it's 11 pi over 6. 11 pi over 6. All right, so what do we know? If we look at these coordinates, it's rad 3 over 2, 1/2, rad 3 over 2, 1/2, and rad 3 over 2, 1/2. All the numbers are the same, the signs are different. So what that tells me is I should be able to just go rad 3 over 2, 1/2, and 1. Ha, what has to change? Ah, this one, it's negative. So this is just rad 3 over 2, comma, negative 1/2. Now, with your Genius Scan, what I want you to do is I want you to take a quick picture of that. I want to see the pi over 6 pi triangle, the 5 pi over 6, the 7 pi over 6, and the 11 pi over 6. This is part of your homework, okay? I'm only going this far, but you can take a shot of that with Genius Scan, and just don't worry about Genius Scan when you get back to it later. Or you can do all your pictures at once. You can put your pi over 6s on, take your picture, put your pi over 4s on, take your picture, put your pi over 3s on, and take your picture. Because I am not going to do the other two with you. But when you finish your unit circle homework piece today, you will have all the coordinates for these 4. And what I'm hoping you're going to see is, I'm really hoping you're going to see is, you're going to see pi over 4 bow tie. You just saw the pi over 6 bow tie. You can see the pi over 3 bow tie. I'm giving you multiple representations of the unit circle because for all of you guys in this class, some of you will really see it in one of the different representations. Maybe not all of them, but like the bow tie, I happen to really like. I just happen to know the unit circle really well because I've taught it for 20 years, right? Or whatever it is, 17 years, 18 years, something like that, in pre-calc. But here's the other piece of the homework that goes along with cutting out the triangles that we just used over there and building the triangles and building the unit circle here. Then I want you to come back. And so this is just 0, and it's all the way around to 2 pi, even though it doesn't have 2 pi on here. 2 pi would be the next one, but 2 pi would also be 0. So 0 radians is 0 degrees. The x-coordinate, we didn't do it. What is the x-coordinate? It's 1, 0. Remember, this is a quadrantal. You need to know that word because it comes up, okay? The quadrantals are 0, 90, 180, and 270. So since I'm labeling, I'm going to go ahead and label the 90, and the 180 is negative 1, 0, and 0, negative 1 for 270. So then to fill in my table, my x-coordinate, all I have to do is go look at it. My x-coordinate is 1. My y-coordinate is 0. My location is 1, 0. Okay? Oops, I kind of cut you off there. 1, 0. Now, I've got pi over 6 done, so now I can do pi over 6, I can do 5 pi over 6, I can do 7 pi over 6, and I can do 11 pi over 6. I'm only going to do pi over 6 with you. Pi over 6, the degrees is 30 degrees. Okay? The x-coordinate is rad 3 over 2, and the y-coordinate is 1/2. It might be a good idea to learn to recognize the decimal equivalent of this, of 8.8660, and the decimal equivalent of this, which is 0.707. So I'm going to write rad 3 over 2, comma, 1/2. And I want you to fill in the entire table. So I'm going to give you some time in class to finish this off. If you had your triangles cut, great. If you didn't, great. But I want to see this filled in. I'm not worried about the degrees here. I also emailed to you another unit circle that has all the degrees on it. Then you should practice putting in the radians. You have some blank unit circles. The best thing you can do to learn your unit circle is just once or twice a day, fill one out. If you're going to print them out at home, print them on front and back. That way you have 2, or shrink it down, make them smaller if you write small, and put 4 on a page. But the only way to learn the unit circle is to practice it. It's like multiplication facts. Anyhow, that's long enough for this video. That's enough to get you started so you can build your unit circle. Have fun.